Hi everyone. I'm working on a little presentation for middle school and high school students about understanding area and in particular understanding how we get the formula for the area of a circle and how to think about circles. And I thought it might be interesting to just show a slightly more involved version. It's still going to be very quick. I'm calling this the 5-minute area. We'll see about how long it takes. So we'll move quickly. Okay. What is area? We think we know. I guess we know. It's the amount of space inside a shape or boundary. Now, why do we care? We like to measure it. Why do we want to measure it? Because we want to know how much space things take up. It's useful to know when we're planning. We want to know how much space a table, or a room, or a field, or an apartment, or a house, anything, you name it. How do we compare them? We have to have some measure. Area is what it turns out to be. Now, I'm fascinated by circles because they are such efficient ways to make area. We see them a lot. We see them in particular in the kitchen, pots and pans and cans. Why is that? Well, one of the reasons is that round shapes make the best use of material that we have to try to make something. A pot or a pan is made out of metal. You use the metal most effectively, we'll see, when you make it into a circle. Same thing with cans, where companies that make canned foods, obviously one of their big costs is aluminum. So they want to buy as little as they can to put as much food in it as they can. Okay, we will get to that. And let's move on. Okay. I want you to think about a piece of string. I love this exercise. Think about a piece of string, long piece of string. Okay, let's show more slowly. I actually don't have the string. Thought about taking off my shoelaces, but I'm such a fool with these things I might not figure out how to put it back. So imagine a piece of string. Let's try to shape this a few different ways. We can shape it into a rectangle. We can take the same string and shape it into a square, which is just a special rectangle, as you know, with equal sides, and then we can also shape it into a circle. Okay, one piece of string shaped a bunch of different ways. Now, what's interesting, since this is a discussion of area, let's think about how much area we cover with that piece of string. If it's just a line, we don't cover any area. There's no space inside of it. There's some space inside a rectangle. We're able to get somewhat more space when we turn the rectangle into that special rectangle we call a square, and it turns out we get the most space when we make the rectangle, when we make the string really into a circle. An architect friend of mine explained this to me many years ago when I had the wrong answer to this question. Okay, so how do we figure out area? Let's go back to rectangles and squares. Imagine that we have an 8-inch piece of string. This turns out to be a nice easy number to use. To help explain this. It would work with any number, but this is convenient. So we're going to take this 8-inch piece of string. First, we're going to make it into a rectangle. The rectangle is going to have 3 inches the long way, 1 inch the short way, okay? So the perimeter, and perimeter, you know, I love Greek and Latin. Perimeter comes from the Greek words peri, which means around, and metros, which gives us the word meter for measure, which I imagine you know. So measure around. So for a rectangle, measuring around 3 by 1, 3 plus 1 plus 3 plus 1, that gets us back to the 8 inches. Now, let's imagine that we're breaking this rectangle into squares, one by 1 each. And as you can see, we have 3 of them. Now, when we make the string into a square, to use the same 8 inches, but each side has to be the same, then we can see quickly 8 divided by 4 is 2 inches on each side. But we're able, when we're making this square, we're now able to make 4 of these 1 by 1 squares. So we get our area from 3 to this certain rectangle to 4. So we can see that when we make a rectangle, the most efficient rectangle for making area is a square, okay? But, and see, I used to think that if you took that piece of string, the square was the best you could do for area, as I said. Then my friend the architect said, no, actually, Bill, you fool. A circle would be a lot better. And I wanted to figure out why. I thought about it. I said, yeah, you're right, but let's see why. So here's how I did it, and you may have a better way. First, imagine drawing a circle inside a square, okay? And we have the radius of the circle generally are. In this case, let's just say it's 1 inch. Keep sort of with our old example. So that means the whole side of the square, the circle's right inside the square, the whole side is 2 inches, okay? And we can see that we have 4 of these 1 by 1 boxes. So the area of the square is 4 inches. Since we said r is 1, it would be 4r squared if we just sort of said r, which could be anything. I have said 4r, it's really 4r squared, and that's important. Now, the area of the circle, we can see, is less than the area of the square because the circle, as you can see, fits inside. You can see very clearly that the circle's area is somewhat less. We have those portions in the corners where the circle does not cover the area. The circle covers most of the area, but not all. How much of the square does the circle cover? Well, I once saw a very interesting computer program that said it showed a bunch of simulated darts generated by a random number generator that all had to be inside of the square, but not all had to be inside of the circle. Kept generating more and more and figure out what percentage of the darts, of the simulated darts that landed inside the square were also inside the circle. And it turned out that it's about 78.5%. Well, guess what? If we multiply 78.5 times 4, 4 is the area of the whole square, we said. 78.5 times 4 gets us 3.14. Sound familiar? It should. That's pi. Okay, so a square, if we think of a square, area 4, basic 1 by 1, 4 of them, the area of the circle would be pi. And more generally, since we can use r as the radius instead of just saying it's 1 in this one example, pi r squared is the area of a circle. Okay, now English and Egyptian, English weren't even around that far back. Egyptian and Greek mathematicians have been trying to calculate, or were trying to calculate, pi for thousands of years before they had the computing power that we have now. So let's just go one step further. So now we know how to figure out the area of a circle, and we understand where pi comes from. But let's go back to our earlier question of how come a circle is more efficient use of space, use of area? How does a circle make the best area given that we have a finite piece of string or a finite amount of material? Okay, first of all, we can see that this circle that we drew inside the square does not use up all the string. You can see that because imagine if you start at the top of the square in the middle and had to walk all the way back around. If you go around the square, you're sort of going the long way. You can walk around the circle, and as you can see, that's a shortcut. In other words, you're not using the whole piece of string, you're only using part of it. So let's figure out, what if we did use the whole string to make a circle? Clearly, we could make a bigger circle. How much bigger? Well, the string has length of 8. So we're going to make the perimeter of our circle 8. It was less here before, clearly, because the square had perimeter of 8. So r, the radius, now has to be bigger than 1. How much bigger? Well, we're going to go to our formula for the circumference of a circle. Circumference is just another word for perimeter, but it applies specifically to a circle. Circumference comes from the Latin words for carry around. Okay, so circumference of a circle is 2 pi r. In a longer video, I can explain how we get that, and it involves calculus, but let's just, most people know that, a lot of people know that anyway, so we'll stick with 2 pi r. We rearrange that algebraically, we get r equals circumference, the radius equals the circumference divided by 2 pi. So we now know, just with a little more algebra, if with an 8-inch circumference, that the radius of a circle with 8-inch circumference is 1.27 inches approximately. Now we go back to our formula, pi r squared, for the radius, for the area of the circle. We figured out r, and just by applying that formula, we get a circle that has area 5.06. Now compare that to the square. The square was only 4. So circle's a lot better than square, right? And that's the best way to use your material. That's the best way to use your string. So if you're trying to maximize area, use a circle, now that we know how to get pi. Thanks very much.